into error intervals and bounds. Just before we start, a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so when we are looking at error intervals and bounds, what we're actually looking at is numbers which have already been rounded and the impact that that can have on the actual accuracy of our answers. Now obviously if we've rounded a number, we've gone from the original correct accurate answer to something that is less accurate before. So what we're going to look at is how we can actually show the values that we could have had. And so the mass of a rhino is measured as 1200 kilograms to the nearest 100 kilograms. So what I've done is I've set up a little number line. And the reason for that is that I want to just mark on the values that we have just been given. So we've got 1200 kilograms is the actual value that we've been given. Now it says that's rounded to the nearest 100 kilograms. So that means that the next nearest 100 kilograms would have been 100 kilograms below 1100 and 100 kilograms above 1300. But what we want to do is we want to find the two values, the upper and lower bound of this information, the smallest number which would round up to 1200 and the biggest value which would round down to 1200. And basically that always comes from just splitting this number line in half. So what is halfway between 1100 and 1200? Well, it's 1150. And halfway between 1200 and 1300 is 1250. And so what we're saying is if we choose any value between 1150 and 1250, it would actually round to an answer of 1200. Anything below this point of 1150 would round to 1100, and anything above 1250 would round to 1300. And so this is the key area between 1150 and 1250. And so that rhino will have a mass that is at least 1150 kilograms. It will at most have a value of 1250 kilograms. But you'll notice here that I've used two different symbols. The first symbol has the equal to sign underneath it. And the reason for that is that if I had a value of exactly 1150, it would round up to 1200. But if I had a value of exactly 1250, that would round up to 1300. And so I don't want to include that value, I just want to go all the way up to it. In fact, almost like saying 1249.9999999, on and on and on. Okay, but to make it easier, we just go with the nice round number of 1250. So, same situation, the attendance at a rugby match is 23,000 people, correct to the nearest 1,000. So the same thing applies. We just want to see, well, what number of people could there have been? And so I'm going to start in the middle of my number line with the number that I've rounded to, 23,000. And then the two extreme ends of my number line are going to be this 1,000 below, so 22,000, and the 1,000 above, 24,000. And the two values that I'm interested in are the ones which split that number line in half. So what is halfway between 22,000 and 23,000? Well, it's 22,500 and 23,500. Anywhere in this area would round to 23,000. And so the number of people at that match, the attendance, let's call it A, well, it could have been 22,500 exactly, but at most it was 23,500. And so it had to be below that value in order to round to 23,000. 40 people on a bus, correct to the nearest 10. So we're going to go with the same idea. 40 people in the middle. If it's to the nearest 10, then that means we want to go down to 30 and up to 50, and we want to split right down the centre. So 35 and 45. So the lowest possible number that I could have had was 35, the absolute maximum was 45, and so my inequality, and again let's call it P for people, 35 less than or equal to P and less than 45. So we include 35 because that would round up, but we don't include 45 as that would round to 50. And then the length of a piece of wood is measured as 3 meters to the nearest meter, and so that middle value has to be 3. In this case, if it's nearest meter, then we just need to think, well, the meter before that will be 2 and the meter above it will be 4. And in this case, when we split this in half, well, what is halfway between 2 and 3? Well, it's actually a decimal. It's 2.5. Halfway between 3 and 4, it's 3.5. Anything in between those two values would have rounded to 3 meters, and so anything from 2.5, and again let's call it L for length, to 3.5. We should also use our units there, meters. 2.5 less than or equal to L, less than 3.5. And the height of a door is measured as 2 meters truncated to the integer meter. Now that is a very important phrase. We've used the word truncated there. We haven't actually rounded this time. So we need to remember what truncate means. To truncate means to cut off. Okay, and so when we're dealing with this one, we're going to draw our 2 meters right in the center. Now if it's been truncated to the integer meter, well, the next integers would be 1 meter or 3 meters. But in this case, because it's been truncated, it means it's just been cut off. And so these values here, anything in this section from 1 up to 2, well, they would not work because they would all truncate to 1 meter. We would just cut off everything after the decimal point. And so when we are dealing with truncation, the lowest value possible is always the number we actually were given as our value. The largest value it can be would take us up to the next point. And so in this case, for our truncated height, let's call it h, well, it could be as small as exactly 2. But the largest it could possibly be would be 3, no further than that, but not including 3. So next we're going to look at the effect of rounding to decimal places. So in this first question we've been told that the width of a triangle is measured as 5.7 centimetres rounded to 1 decimal place. So just as we did before, the central value is going to be the one that we were given, 5.7. But because it's 1 decimal place, we need to think about what that's meaning. And so it's only dealing with the number after the decimal point. So the one before that, the lower value, would be 5.6, and the one above that would be 5.8. So that is the 1 decimal place effect. But the same process comes in. We still need to split in half because only the values here would round to 5.7. So what is the number that is halfway between 5.6 and 5.7? Well, it is actually 5.65, and at the top end 5.75. And so the error interval this time, if we're talking about width, let's call it W, well, it could include 5.65. So if it was 5.65, that would round to 5.7, but it would go up to 5.75, but in this case not including the 5.75. The fraction 1/7 is 0.143 correct to 3 decimal places? So the 0.143 is the value which is right in the centre of our diagram, but that's correct to 3 decimal places. So where is that acting? Well, it's right here at the end of the number. And so what would be the value below that? Well, it would be 0.142. The value above it, 0.144. What would be halfway in between? Because it's only, again, the numbers in the middle which would work. And so halfway in between, 0.1425, and the values above, 0.1435. And so that value, 1/7, well, that is at the smallest, 0.1425, and at the highest, 0.1435. A faulty calculator can only display 2 decimal places of an answer. It shows 23.34. Now, we've got to think carefully about this, what it actually would mean. If the answer is 23.34 on the calculator, but it's faulty, well, that would mean that the digits may continue afterwards. What it doesn't mean is that it could be a value lower than that. And so this is actually a version of truncation. Again, if we look at the 2 decimal places, then we would be dealing with 23.33 and 23.35, but we know straight away that these values are not going to work. It would be the absolute smallest possible value, 23.34. So let's call it D for display. That is the absolute minimum, 23.34. Going beyond that, it could though go up to, but not include, the 23.35. And so any value up to that would work. And finally, we're going to look at the effect of rounding to significant figures. So in this case, the attendance at a football match is 40,000 correct to 1 significant figure. So same process, we still want to write the 40,000 in the middle of our number line, but we need to think first what 1 significant figure actually means. And so in this case, 1 significant figure would mean it was rounded after this number 4. And that 4 is in the tens of thousands. And so we are dealing with 10,000 less below it at 30,000 and 10,000 more above it at 50,000. What would be halfway this time? Well, halfway in between. What is halfway between 30,000 and 40,000? It's 35,000. What's halfway between 40,000 and 50,000? It's 45,000. And so in this case, the attendance, which again we'll call A, the smallest it could possibly be would be 35,000. The largest it could be, and again it's not including this value, is 45,000. The Jurassic period began 200 million years ago, correct to 2 significant figures. So again, this number here is going to be in the middle, so 200 million. And it's correct to 2 significant figures, which means 1, 2. And so in this case, it was rounded here, which means it was actually rounded to the nearest 10. And so the nearest 10 would be 190 million or 210 million. And so, again, halfway points. What is halfway between 190 and 200? Well, it's 195. What's halfway between 200 and 210? It's 205. And so, the Jurassic period started between 195 million years but less than 205 million years ago. So next we come to the diameter of a basketball, which is 9.55 inches, correct to three significant figures. So straight away 9.55 is going to be the value in the middle of our number line, and it's gone to three significant figures, which actually means that it's been rounded right here at the end. And so what does that mean? Well, it's actually been rounded to the nearest hundredth. So we need to take 1/100th away, so 9.54, and add 1/100th on 9.56. What's going to be halfway in between those two values? Well, between 9.54 and 9.55 is going to be 9.545. And between 9.55 and 9.56, well, that's going to be 9.555. So when we deal with the basketball, it could have been at least 9.545 inches and at most 9.555 inches. And finally we start looking at truncation again, but significant figures. So the age in years of a maths teacher is 30, truncated to one significant figure. So first of all, we know that means 30 is right in the middle, and it's been truncated to one significant figure. So it's been truncated here. Now that means that we're talking about the nearest 10, 20 or 40. But the thing to remember here, the word truncated, it means it's been cut off, it hasn't been rounded, and therefore none of these values work. The absolute lowest value it could have been was 30. So the age of the maths teacher is at least 30. And it could go all the way up to, but not include, that age of 40. And therefore we know that that teacher must be somewhere between 30 years old and 40 years old, but not including the 40. Okay, so we end with the exam question. It came from the Edexcel paper in June 2017, Foundation Paper 3. Now that means it's a calculator question if we need it. And I will just say though, question 23, it was one of the very last questions. So it is actually more like a crossover question, a grade 4-5 topic. And so we've been told Harley's house has a value of £160,000, correct to two significant figures. Write down the least possible value of the house and write down the greatest possible value of the house. Now this is just another way of asking the same sort of question that we've been dealing with so far. We're just not going to write it as an error interval. We're just going to write down the smallest value and the biggest value. So we're still going to begin though with our number line. And we know that it's rounded to 160,000. So that is going to be the central point. It's two significant figures, so that means it's been rounded here at the 10,000 value, and so the 10,000 less will be 150,000 and 10,000 more will be 170,000. We need to know what are the halfway points. So what is halfway between 150,000 and 160,000? 155,000. Halfway between 160,000 and 170,000, 165,000. And so the first question is the least possible value. Well, the least possible value is this one right here. It is £155,000. The greatest possible value. Now, an acceptable answer here is this one. £165,000, and that is because when we are dealing with upper and lower bounds, generally we just use the most rounded values. But actually in this case there are other values which are acceptable, and that is because we're dealing with money. With money we know what the values actually go up to, and so we want to find the very last value which would be less than £165,000. Well, that would be £164,999.99. And so we can be even more accurate in this case because we know that that is the absolute maximum. But this one here is perfectly acceptable, and so is this one.